Hello everyone and welcome back to Life with Technologies YouTube channel. I hope you're doing well and thank you so much for watching this session. So this is episode 12 of our Juniper Lab simulation series, and in this episode we are demonstrating how to implement BGP MPLS L3 VPN on Juniper MX devices. So we know that BGP MPLS L3 VPN is a very common technology that is used on service provider networks to ensure that we can isolate customer services into their own VPN instances. So we are able to carry these services without mixing them on the service provider network. And the good thing is it allows us to use the same network infrastructure to serve different customers. So if you have 100 customers that requires to communicate with the other 100 customers, you can use the same existing infrastructure to carry their services transparently on your service provider networks. So with L3 VPNs, we are able to create VPN instances or routing instances on Juniper, and then we will place this customer into those respective VPN instance depending on how they require to communicate. So one of the things that you need to understand, of course, about the routing instances or L3 VPN are things like the route distinguisher, the role of the route distinguisher, the VPN targets, what are the roles of the VPN targets. So we'll be discussing through them as we go through the training. So this is the topology that we are using. You can see that we have the MPLS backbone, and our MPLS backbone has PE01, PE01 and PE02, and we'll be using OSPF as the IGP protocol in our MPLS backbone network, and we have BGP AS number 65000 as the BGP number that we'll be configuring in our MPLS backbone. So in total, we have 4 customers, 2 customers in VPN A, and you can see that C1 is connecting to PE01 on in VPN A, and then needs to communicate with CE2 that is connecting to PE02 in VPN A. Then we also have VPN B. So VPN B has CE03 connecting to PE01 and CE04 connecting to PE02. So we need to ensure that we have communication between customers in the same VPN instances. So CE01 should be able to communicate with CE02, and CE03 should be able to communicate with CE04 in the same VPN instance. So this is the topology. You can see the IP address have been assigned, the point-to-point IPs, and also the system IPs for the different devices, from PE devices, the P01 and also the PE02. We have also assigned loopback IPs on the CEs, which will be importing into BGP and use them to test the connectivity between the different customers. So for the implementation steps, these are the steps that we'll be following. Remember, when you are doing BGP MPLS L3 VPN, you need to do some basic configurations. You need to do the IP address configuration. You need to configure the sysname. That is one of the best practices. You need to configure the host name on all the devices. You also need to configure IGP in the MPLS backbone. Remember, we'll be doing BGP configuration between PE01 and PE02 so that they are able to exchange VPN routes. So we need to have IGP, and in this case we'll be using OSPF in our MPLS backbone to ensure that we have connectivity between PE01 and PE02 before we configure BGP. So we are implementing BGP MPLS, so we need to configure MPLS and RSVP in the MPLS backbone. So we are using RSVP as the signaling protocol. You can use LDP or the label distribution protocol. So you need to enable MPLS on these routers. You need to activate MPLS and RSVP on the interfaces in the MPLS backbone. And then once we've done that, we'll go ahead and configure IBGP. This is VPN Vivo peering session between the PEs. So we need to establish BGP VPN Vivo BGP peering session between PE01 and PE02. And again, once we've done the BGP session, it means we've completed the configuration of our MPLS backbone. The next step is to now configure the VPN instances on the PEs. Remember, the VPNs or the routing instances are only configured on the PE devices. We don't do any VPN instance configurations on the P devices. For them, they will just be doing the label switching. And then once we've done the VPN instances on PEs, we need to bind the interface towards customers on those VPN instances, on the respective VPN instances. So for example, CE01, the interface connecting to PE01, it will be bind to VPN A, and then C03 we need to bind the interface connecting to C3 to VPN B. And then we need to configure EBGP peering session between PEs and CEs. So we are using EBGP as the PE-CE routing protocol. So we need to configure EBGP peering session between these nodes, and then we need to do the verifications to ensure that the peering sessions are up. And the seventh step will be to configure CEs. So on the CEs, we also need to configure the host name. We need to configure the interface parameters. We also need to configure BGP sessions towards the PE devices. And finally, we need to import the loopback IPs to BGP so that they are advertised to the remote CEs. And then once we've done that, we can do service verification. And for the service verification, we just need to ping CE01 should be able to ping CE02 under VRF VPN A, and then VPN B also we need to be able to ping from CE03 to CE04. So this is the implementation steps, and we will be switching to the EVNG and logging into the nodes so that you can see the step-by-step implementation. So we've already prepared the script, and the configuration will be done step by step so that you are able to understand and master how to do this implementation. Just a kind request that before we switch to the implementation steps, kindly remember to subscribe to our channel. And also we have other different trainings on our channel. We have lab simulations on Huawei, we have lab simulations on Nokia, and if you haven't checked them out, please check it out, and remember to support by commenting, liking, and sharing those videos with your connection. So to the implementation steps and logging into the EVNG. So this is the lab setup in EVNG. You can see that the same topology, we have these different nodes. We have P1, P1, and P2, and we have the VPN instances. We have C1 and C2, C3 and C4 in VPN B, and the IP address are as per the topology that we've discussed before. So I'll open the sessions. So I need to log into C1, C2, C3, C4, and the PE devices, and also the P devices. So once I'm logged in, we need to do the configuration step by step. So if you check from the configurations, try to from the configurations, we need to start by doing the basic configuration. We need to configure the host name and IP addresses on the nodes in the MPLS backbone. So starting with PE01. So when you are doing configuration on Juniper devices, first you need to be in the configuration view. So you use the configure keyword. Then once you've changed to the configuration view, the first thing that we do is to set the host name. So you set system host name, you provide the host name that you've assigned to the device, and then we'll do interface configurations. So for the interface configurations, you can see that we have two interfaces. I mean, we have three interfaces. Two interfaces will be connecting to C1 and C3, and then the G002 will be connecting to P devices. So this is the link from P1 to the P router. And then we will also configure the loopback interface. So you configure the loopback interface, you configure the point-to-point IPs, you assign description to the interfaces. So these are the basic configuration that we need to do on PE01. Very straightforward, very easy to understand. So I'll start by configuring the host name. So you can see that currently we don't have a host name configured. So I'll click. So I set system host name P1. We haven't committed, so it's still not yet changed. So we need to do the other configurations. So I'll copy it slowly and paste. And then we do the configuration for the other interfaces. So you see this one is reporting an error, but it should be okay. So this is which line? This line. So for the simulation environment, sometimes it may report some errors which you don't expect to find when you are doing the labs on a relay device. So if you do show pipe compare, you can see that these are the configurations. We have GE001, we have the host name, we have GE002 with the correct IP address, and then we have the loopback interface. So you can do commit check to check the syntax of the configuration just to ensure that it's okay and aligned. So it means that the configuration check is succeeded. I'll do commit and quit so that the configuration take effect. And while we are committing, we can move to the next device. So you can see that the host name has changed to P01. So the next device, this is P01. I'll need to do similar configuration, configure the host name, configure the interface parameters. And then configure the loopback interface. So you can still do show pipe compare to see what you are applying onto the system, because you may be doing some changes that are not required, or maybe you are changing some existing parameters. So it's always good practice to show pipe compare so that you are sure the changes that you are making on the system. So I'll do commit and quit, and then we need to do on P02. So P02 we have similar configurations. So on P02 need to configure and then copy this. Copy the other configuration. So this is for the interface parameters. Description L3. I'll copy the remaining configurations and apply. Hope there will be no errors. You can see that there are errors. So we may need to copy this. L3 VPN. Show pipe compare. So we have the parameters. Can do commit check also. So for the routing option, the route ID will be configuring in the upcoming steps. That's why I haven't done it here. And then commit and quit. So on P1, if I show interfaces stars, you can see that we have interfaces assigned IP addresses. You can see this is G00, and then we have this interface also assigned with the IP address. We have for loopback, if you check on the loopback interface, we also have 1.1.1. You can try to ping the point-to-point 10.10.10.1. This is how you do the ping on Juniper devices. So you run the ping and then you specify the destination IP. It's same with the other routing devices from other vendors. So you can show interface stars on P1. You verify the parameters. On P2, we can do the same. Show interface stars. You will see the parameters, so we can verify that that's okay. So we need to do second step, which is we need to configure OSPF. So for configurations on OSPF, you first need to remember, many times you need to create an area and then you need to activate OSPF on the interfaces. One thing that we are also doing is we are enabling traffic engineering. Remember, we are using RSVP, which supports traffic engineering. So you can go ahead and enable traffic engineering on OSPF. So we activate OSPF area 0 and enable it on the interfaces. Loopback 0, we normally make it passive so that it doesn't try to form any neighbor relationship. It's active advertising OSPF, but it will not form any peering relationships. So we need to do this. You can do show pipe compare. These are the configuration. Commit, just commit. On P01 we do the same. We have, this is P01, we have multiple interfaces connecting to PE01 and PE02 and the loopback interface. So I'll do commit, and then on PE02 we also need to do the same. We activate OSPF and activate traffic engineering. Once we've done that, remember OSPF actually is one of the most common routing protocols, IGP, and you really need to do practice. We already have some videos demonstrating how to configure OSPF on Juniper devices, so you can go through them just to refresh your knowledge and do some practices so that you are familiar on how to configure and troubleshoot OSPF on Juniper devices. So once we've done this, we can go ahead and run show OSPF neighbor brief. You see that we have one adjacency, and this adjacency is towards 1.1.1.2. So it means that if I do show run routes protocol OSPF, you expect that you've learned some OSPF routing information, and you can see that we have the routes. On P1 we can do the same, run show OSPF neighbor brief. You see that we have two adjacencies, one towards 1.1, another one towards 1.3, which is PE03. Can do the same, run show OSPF neighbor brief. You see that we have one adjacency. I can show route, run show route. See that we have different routes. You can see that we have 1.1, 1.2, and 1.3, which is the most important because we need to be able to reach the loopback IPs so that we can establish BGP peering sessions. On P1, if I rerun, you expect that you've now learned an extra route, which is the loopback IP of PE02, and we can run ping 1.1.3. You see that it's reachable. From the other side, on P1, we should be able to ping the loopbacks of the two routers, 1.1.1 and 0.3. So that one proved that the configuration or the setup for OSPF, our IGP, is okay in the MPLS backbone. So we need now to go ahead and do further configurations. You can check on the interface, the OSPF interfaces. You can check the OSPF database. You can check the SPF logs. You can check the LSS. All those ones you can check when you are configuring OSPF. So just remember that we already have videos demonstrating how to do this, even on Nokia and Huawei. So you can check out those sessions on our channel and have a look at them, and they will help you to understand how to configure and troubleshoot OSPF on different vendors. So after the verification, the next step is to now configure MPLS and RSVP in the MPLS backbone. So remember, MPLS is the technology that uses label switching instead of the IP lookup. So we need to activate MPLS. And remember, we are implementing BGP MPLS VPN. So MPLS plays a very crucial role when you are doing the VPN implementation, both layer 2 and layer 3 VPNs. So these are the configuration that we need to do. Starting with P1, we are enabling MPLS family on this interface, RSVP on the two interfaces. This is interface towards P01 in the MPLS backbone, and then we are configuring a label switched path towards P02. So this is it. You also need to enable MPLS on the interface, on the physical interface towards P02. So this is it. I just copy these configurations, go to P1, apply. Let me copy this again. It didn't pick all of it. And then we need to activate MPLS on this protocol. You do show pipe compare to check which configuration changes we've done. I'll commit. Then we need to do the configuration on P01. So P01, remember we have two interfaces connecting to the two provider edge routers 01 and 02. So you need to activate it, and even on the loopback interface. So on this device, I'll run the commands show pipe compare and then commit. Finally, we need to do the same on our provider edge router 2. So I'll copy, go to provider edge router 2, paste and commit. You can still show pipe compare to verify that the commands that you are applying are the correct ones. So you can run show MPLS, maybe interface. It will give you the MPLS interfaces. Run show MPLS interface. You can see that the two interfaces have been activated with MPLS. Run show, you can see other parameters. If you do MPLS and use a question mark, you can use the LSP, you can check the interface, you can check if you have static LSP, if you have some other parameters configured, you can always check these parameters. So I'll just check the interface, and you see that we have this interface activated with the MPLS. So the next step now, we need to configure BGP peering session. So remember, these are our provider edge routers, P1 and P2. So we need to establish BGP peering session, VPN before peering session, so that these two routers will be able to exchange VPN routes between them. So when VPN routes are advertised from VPN A in CE1 to P1, P1 should be able to advertise those routes towards P2, and then P2 should be able to install those routes in their routing table and propagate them to VPN A through BGP. So these are the configuration that we need to configure, starting with P1. So you can see that we are first setting the router ID. So we need to set the router ID, and the router ID is normally set using the loopback IP. This is the best practice. You set it using the router ID, the loopback IP, which is normally unique. And then we are specifying the autonomous system number as 65,000. We are configuring EBGP. So we create a group EBGP. This group is type internal. We specify the local address. We specify the neighbor and then the family. This is iNet VPN. So we are using iNet VPN for the BGP peering sessions. So starting with P1, we need to apply this again, show pipe compare, to see the active configurations, that the candidate configuration that will be applied once we do a commit. On P2, we do the same. We've configured the router ID. We've specified the autonomous system number. We've created a group. So the good thing with creating groups is we are minimizing the number of commands. Imagine you had like many BGP peering sessions to configure. So it means you will have to configure multiple times, same lines, like you specify the local address, you specify the maybe the local address for every peer. You need to specify things like the export policies, and maybe they are using the same export policy. So you minimize the number of lines that you need to configure when you are using BGP peering groups. So on P2, we need to do the same. We'll configure the BGP session. I do show pipe compare, and then I'll commit, and we can verify the BGP peering status between P1 and P2. If I go to P1 and run show BGP summary, you can see that the session is still active, so it will take some time to come up. So you see that now the peering session is established, which is good. So the state is now established. And you can see the BGP L3 VPN. We are not receiving any prefixes, but once we start advertising, then we expect to be receiving some prefixes between P1 and P02. So the BGP peering session is up between P1 and P2. Again, run show BGP summary. on this router, you can see that it's also established, and many other parameters, the in packet, out packet, the number of routes, the peer, it's 1.1.1, the other side it's 1.1.1.3. So we've verified that our BGP peering session is up. The next step is to configure now the VPN instances. So when you are configuring VPN instances, one of the things that you need to do is you need to give the VPN name. And on Juniper devices, you also need to specify the instance type. So this is a VRF. So you need to specify that this is a VRF, virtual routing and forwarding, or a VPN instance as it's called on Huawei devices. And then you need to give the route distinguisher. So the route distinguisher will be able to make the routes from customers unique and allow them to use overlapping addressing space. So in this type, we are using the type 1 route distinguishers. You can see that we are using the loopback IP and a random number. This is a type 1 route distinguisher, which is recommended. And then we are setting the VRF target. So VRF targets will control the route import and export between the PE devices. So the devices in the same VPN should be having the route target so that they can exchange the routes. So this is the VPN target, and then we are putting the interface towards C1 in this VPN-A. So I'll copy this, and then go back to P1, apply, and then for VPN-B we are doing the same. We are also specifying VPN-B instance type is VRF. We are configuring the route distinguisher, same. We are just changing the last number, but the loopback IP is used, which makes it a type 1 route distinguisher. And then we specify the route target or the VPN target, which will control the route import and export, and we bind the interface toward the CE to this VPN. So I'll configure this. I need to copy this one again. So if I do show pipe compare, you can see the lines. We've configured the VPN instances, we've specified the route distinguisher, we've specified the VRF targets, we've bind the interfaces into that VRF instances. So this one makes it easy both for VPN-A and VPN-B. And then we need to do the configuration on PE2. So PE2 will do the same. The only thing that is changing, we are changing the route distinguisher. We are changing the loopback IP that has been used in the type 1 route distinguisher to 1.1.1.3. And then we are maintaining the VPN targets. So VPN-A will use the same VPN target as it is on PE02, and VPN-B will also use the same VPN target so that they are able to exchange the VPN routes between the nodes. So on P2, I need to apply these configurations. I'll copy the interfaces command again so that it takes effect. Then we'll do for a VPN-B. So for VPN-B, we apply, again, I need to copy this command again. So I'll do commit. So we've configured the VPN instances, we've added the interface towards the customer, we've specified the route distinguishers, which are type 1 route distinguishers. We've also specified the VRF targets to control the route import and export. So the next step is to now configure the EBGP peering session. Remember, we are using BGP as our PEC routing protocol. So you need to configure EBGP peering session in the respective VRFs towards the customer. That's why you can see that we are setting the routing instance VPN, and then we are specifying the BGP peering session towards that customer. So we have C1, which is in VPN-A, and we have C3, which is in VPN-B. So we need to do these configurations on the PE so that we can have EBGP peering sessions towards the customer, and then we are able to exchange the routes from the customer. So I'll start with P1. First, I need to commit the previous configurations. Then I have these. Let me copy it section by section. So this is the first section. I'll apply. This command hasn't taken effect. And then we'll do the second section. So this one, we need to specify the correct IP address. Now I can do show pipe compare to ensure that we have the correct configurations. You can see that for VPN B, we may need to, because when we are doing the configuration, it picked some wrong commands. So we just need to delete. And then I'll do 172.0.0.0, so that when I show pipe compare, you can see that these are the configuration that we are applying on P1. I'll commit. And then we need to do similar configurations on P2. So P2, we have the VPN and VPN B, which is towards C2 and C4. So I'll do the configurations. This one again, we need to provide the correct IP address. Then we'll do the same for VPN B. So you need to specify the correct AS numbers. And remember, this is external, so you need to specify that the group C4 type is external. This is not IBGP, this is EBGP. So you need to specify the correct parameters for the peering sessions to come up. If you define some of these parameters, the BGP peering sessions will fail to come up and it will take you time to troubleshoot. So when you are preparing your script, you always have to cross-check everything and ensure that it's okay. So the next step is we need to now configure the CEs, and these are the CE configurations. So for the CE configuration, very straightforward. You need to configure the host name, you need to configure the interface parameters, you need to configure the router ID, you need to configure the autonomous system number to the correct number that you've defined, and then you need to configure the BGP peering sessions. And one of the things that we do here, we are also advertising the loopback IP. And this loopback IP, we use route filter. So route filters can be used to filter the route that you want to. So we've configured a policy, and this policy defines a route filter, and this route filter just limits the routes that we are advertising to BGP to 192, 100, 100, 100/32. So all the others, we are rejecting them. So we'll be discussing further how you can use the route filters to control the route import and export. So starting with C1, let me try to copy all these lines and apply. So you can see that it has configured the wrong IP. This is for which interface G00. So I may need to copy this and apply again. Then this, let me try to configure all these lines. You see this one has missed the one for BGP. Let me copy section by section. So we are specifying BGP as external. Then we have a policy that we've configured. We've specified the PRAS correctly to 65,000. And then we need to we need to specify the peering session towards the PE. Then we can now configure the policy. So you see there is a problem again, so we may need to configure line by line. Sometimes this simulation environment may misbehave, so you need to ensure that when you are doing the configuration, you have the correct commands. Then I'll do this. I can do show pipe compare to confirm the parameter that we've configured. So we have the correct parameters apart from this address. So I may need to G00, need to delete. So I'll do delete this, and the IP address it's .0.0. And the mask is 32. Show pipe compare to ensure that we have the correct parameters. So I'll commit and ensure that all the commands are okay. They've picked okay. So this is okay. We check on CE2. So on CE2 we need to do similar configurations. So I'll quickly copy the commands and apply on the router. Then this one. Then for the BGP, so we are on this command, need to specify the neighbor. And finally, we need to configure the policy. For the policy, let me copy section by section. Show pipe compare. So these are the commands that we've applied on this C2. So I'll commit. So I'll finish the configuration, then we can do final verification. So on C3, we need to do the same. So this is C3. I'll start the configurations. Configure the interface parameters. Just need to ensure that the correct parameters are picked on the devices. Then we need to do the BGP configurations. We have the policy. This is AS and then policy. You can see that we are missing that term 1 accept or something. So this is advertise term 1 from route filter. This is the route filter that you need to specify. Then we can copy this remaining part from here so that the action, remember you need to specify the action of either accept or reject. So show pipe compare. These are the configurations. We can commit. And finally, we need to do the configuration on C4. So these are the configuration for C4. Configure the host name. Configure interface parameters. This is 192.100/32. Configure BGP parameters. So I'm just copying slowly so that we can see whether there is any command that has not taken effect. Then we have the BGP configurations, and finally we have the policy. Policy to control the routes that are being imported from direct to BGP on these CEs. So if I do show pipe compare, you can see that we have these parameters. I'll do commit, and while we are committing, we can start doing the verification. So starting with P1, I'll just quit because we've already finished the configuration. If I show BGP summary, you can see that we have the BGP L3 VPN is established towards the PE02, and then we have VPN A, we have an adjacency towards C1, VPN B, we also have an adjacency towards C3, so which means our adjacencies are okay. PE2, we expect the same. We haven't committed some configurations, so I'll do that and then quit, show BGP summary. So this one, it will take some time because we've just committed the configurations right now. So we give it some minutes. You see that towards C3 it's up, towards the other CE it's also up. So we've managed to implement BGP peering session between the PEs and CEs. So if I show route, receive protocol, BGP, and I check from this peer, we expect that we are receiving some prefix, and you can see that we are getting this prefix. If you check again, this is 104.2. We expect that we are also getting a prefix. Let me see. So from C4, we are not getting a prefix. We need to check on C4. This is 104.32. And then if we see 104.2, 104.100, quit, show configuration, display set. So we have a policy, and this policy, it's okay, accept, then reject. Let's check the IP address of the loopback interface. This is 104.192.100, 104.100, which is okay. Run show BGP advertising, BGP routes, no, run show routes, advertising protocol BGP, and then we check BGP towards this peer. So you can see that we are advertising this prefix. When we check on P2, we expect that we should now be getting it. Oh, I've actually indicated a wrong peer. That's why we were not able to see the prefix. So when you are verifying, you need to really check and ensure that you have the correct parameters. So show BGP summary, we have the BGP session established. You can see that we are getting one prefix each on these VPN instances coming from the other side. We are advertising one, we are receiving one, and then for the BGP L3 VPN, you can also see that for the VPN A we have two, VPN B we have two. So of course, one is coming from the other CE, another one is coming from the other CE. So on CEs, if I check show BGP summary, we expect that we have a BGP session up. If I show route, you see that we are able to learn the route from the other side. So this is 102.100. This is assigned on. This is 102. Let me see again on the screen. Oh, we have the 102.100. 102.100 has been assigned on the other side. If you check our topology, you see the prefixes. 102.100 is on CE2. So we are able to learn this prefix. If I ping 192.100.102.100, you see that we are able to ping the IP. So it means that our traffic is able to flow from C1 to C2. But if I try to ping 102.104, you see that we are not able to ping it, and we don't have it in our routing table because these two hosts are in different VPN instances and they will not be able to communicate. On C3, if I show route, you see the route that we are getting now. We are getting 192.104.100. I can ping 192.100.104.100. You see that we are able to ping. But if we try to ping 102.100, we are not able to ping because these two hosts are in different VPN instances. So you can show route. Should it be BGP? There is some option that you can use. Is it? So there are different options that you can have on these devices when you want to see the routes. You can show detail, you can show the forwarding table, you can show the active path, you can see the advertising protocol, the one that we've been using. And yeah, there are so many parameters that you can use to check the parameters to verify the status of the L3 VPN. So if you show route, of course, you expect to find the prefixes and you've learned it via BGP. So this one explains how easily it is to implement L3 VPN on Juniper routing and switching devices. So again, for the configuration steps, you need to configure hostname and IP addresses. You need to configure OSPF in the MPLS backbone. You need to configure MPLS and RSVP in the MPLS backbone. You need to configure EBGP peering sessions between the PEs. You need to configure the VPN instances or the routing instances. And then you need to add those interfaces to add the CEs in the respective VPN instances. You need to configure EBGP peering session between the PEs and CEs so that we have route exchange between the CEs and the PEs. You also need to do the configuration on CEs, and these are the configuration that we've used. Very easy to understand the commands. And for other configuration like OSPF, of course, we've discussed about them before, so you can still go through our previous sessions and they will help you to understand how to implement OSPF on Juniper devices. So just to mention that we also have other trainings. We have Huawei Lab simulations, and you can find that we have a similar implementation, how to implement MPLS L3 VPN on Huawei devices. You will find similar implementation on how to do this on Nokia, just to help you to master how to operate and manage these devices from different vendors. We also have Juniper Lab simulations that will demonstrate how to configure and implement other protocols, OSPF, SIS, BGP in details. And then we have the IP run technology. This is for the recorded videos, and we have our live training session that has been ongoing. You can find all these videos on our channel. So thank you so much for watching this session. I hope you've learned something. I hope you've mastered how to implement L3 VPN on Juniper devices, the MX routing devices. And we will be doing more lab simulations on Juniper devices to help you to practice how to do this implementation. And just a reminder or a request that if you watch this video and you are yet to subscribe to our channel, kindly support us by subscribing to this channel so that you can receive notification whenever we have new videos. Also remember to like, comment and share this video with your connections. Thank you so much for watching, and see you in the next episode. Bye.